To build a phylogenetic tree in UGENE, we need to do a sequence alignment first. So we're going to go to Tools, Multiple Sequence Alignment. In class, we use the Clustdal-W algorithm, but you can use any of them. In this input panel, we're going to input some example data. This example data is just a text file, but it's in a FASTA format. In a FASTA format, you have this caret symbol and a description that can be whatever you want it to be, followed by a sequence, followed by another description, and so on. So we're going to open this example file, and then we can make the output file whatever we want it to be. Output example. And there are lots of settings here, but we can just use the defaults. Click Align. So here we have our sequence alignment between, it looks like, a few animals here. If we want to build a tree, we click this little tree button here. So there are three main ways to build a phylogenetic tree. The oldest way is neighbor joining, the neighbor joining method. And there's also this frequentist maximum likelihood method and this Bayesian tree building method. In our first example, we're just going to use neighbor joining, and we can keep all the default settings, and that'll build a tree pretty quick. So here's the tree in this panel, and these numbers represent a distance. When you're doing a neighbor joining method to build a tree, you end up getting these distance measurements in the matrix that you make while you're building the tree, and that's what these are. So smaller numbers are better. But generally, building a tree with neighbor joining without any bootstrapping can not be very good. It's just not very powerful. The advantage is just that it's very fast. So let's rebuild this tree, and we're going to add one option. We're going to add a bootstrapping option. And essentially what this does is when it's aligning the sequences to build the tree, it'll just take little bits of the sequence out each time and try to build a tree from just a subset of the full sequences and do that with a bunch of different subsets or 100 different subsets. So this will take a little longer to build. There's our little loading bar. And once it builds, we have the same sort of tree, but now these numbers represent something different. Remember, we built this tree 100 times. So this branch, for example, we saw 100 times, like in every single tree that we built, whereas this branch here we only saw in 50. So generally numbers over 75 or so can be reliable. And there are also these other methods that I think we played with in class, but they can be a little more complicated. But we can click them and build them and make lots of different trees.